Todos.
各位好嘛，祝各位
Tu te
平
meus
安
avec
健康
agilité.
快樂。
Et comme un bon nageur qui se pâme dans l'ombre, tu sillonnes gaiement l'immensité
ส
profonde.
วัสดีค่ะสหายในธรณีพ้นพวกเราในธรณีนี้
हमारे
ขอส่ง
दोस्त जो कला में बसते हैं उनके लिए दोस्ती और खैर
الأصدقاء في
सगाली
النجوم يا ليت يجمعنا الزمان
हमारी दिली ख्वाहिश है कि सारी दुनिया में हम रहे
Mae Lakmia.
पृथ्वी के हर
Liebe Freunde, Eid.
Selamat malam hadirin sekalian.
Als Vorsitzender
Selamat
des
berpisah dan
Weltraumforschungs-
sampai bertemu lagi di lain waktu.
Vertreter Österreich, freut mich, Ihnen auf diesem Wege
Hello from the children of planet Earth.
With pictures from space and voices from Earth, this is Neptune All Night.
Information in a totally unplanned for, totally new way. Mike?
It was also serendipitous that in 1977 the planets were aligned in such a way that Voyagers could go Jupiter, Saturn, Uranus, and Neptune, and that occurrence wouldn't happen again for 175 years.
That's
So
right.
we had the right technology in the right window of opportunity, and we were able to launch the Voyagers and do that. So there's a serendipity there as well.
Rod is on the telephone. Welcome.
Hello there.
Good morning. Thanks for calling.
My question is, with the planets, or with the moons around Neptune as well as Saturn and Jupiter, do the moons actually rotate? You know, like our moon on the Earth, it's stationary, but it rotates. Do the moons on the other planets, do they actually rotate, or are they stationary too?
Mike, why don't you take that?
Our moon rotates on its axis and it revolves around the Earth, and the two rates are equivalent, so we see the same face of the moon. That is also the case with Triton. As it rotates on its axis and revolves around its planet, it keeps the same face towards Neptune, but that is not the case of all moons throughout the solar system. It's not a requirement, I would imagine, of a moon. There are many moons that do it in different ways.
And one of them, I believe, around Saturn is tumbles.
Tumbles.
Yeah. Jeff in New York. Good morning, Jeff.
Yeah.
Go ahead.
I was just wondering, I've noticed that, like, you know, the moons around the different planets seem to, like, correlate with the rings around the planets. Is there anything to do with that, like, through the telescopes, like, you know, the way they, you know, the way they revolve around the planets?
Is the question that the moons are in the same plane as the rings are?
Yeah.
Derek?
Yes, they are. In the case of Saturn, we noticed that there, or was it Jupiter? There's a situation in which there were some very finely braided rings that were, in fact, so closely associated that the moons themselves, previously undiscovered satellites, actually shepherded the rings and tended to push materials along through the rings. It was a situation in which there were these two rings that were somewhat braided, and there was a moon outside the rings and a moon inside the rings. And they moved along together in their orbit around Saturn and actually pushed material along around in the rings and held the rings into a position.
But I guess it's not the case for Triton and Nereid.
Not the case for Triton and Nereid, and certainly not necessarily the case for any other bodies in the solar system. But very often we do find rings and moons occurring.
So again,
in
there
the
is
same
no
location.
celestial policeman there who describes that all moons have to move in the same plane as the rings.
No.
Good. Steve from San Diego. Good morning.
Good morning. I was curious to know, in the approach shots to the moon, why you're not able to see stars and other things, I guess just stars, in the background, in the black portion of the photograph.
Are you asking why we don't see stars?
Yeah, why aren't stars visible?
Well, it's just because the sensitivity of the imaging system hasn't been turned up enough. Those moons and planets are so bright, despite the fact that the solar illumination is 900 times fainter out there than on Earth, that the glare, blackens out the background.
There are, in fact, actually some pictures of stars sent, and stars are actually used to help navigate.
Yeah, then they have to be particularly planned for. They try to stay away from bright bodies in the foreground if they want to take bright stellar backgrounds. Also, we always have to remember that the pictures we are getting here are only half the resolution the guys at JPL are receiving from Voyager. We are getting 400 by 400 here, and they're getting 800 by 800 pixels. So they may actually be seeing stars where we don't see them right here.
All right, and Zeke in New York City.
Yeah, hi. Am I up?
Yes.
I just had a simple question. I've been following the flyovers quite intensely from the various planets. And simply put, have you noticed, or has anybody at JPL noticed any possibility of any of these planets or moons sustaining any form of life?
Joyce?
That has not been noticed by anyone.
That would have made big news.
You would have heard about it.
So the chipmunks weren't actually
The chipmunks weren't
we
there.
lied.
We're going to Jeff in Wisconsin.
Good morning.
Morning.
I was curious that I knew that they sent out a Voyager 1 and a Voyager 2. What happened to Voyager 1?
Joyce?
Voyager 1 passed by the planets Jupiter and Saturn and had very successful encounters there. And then it was planned and carried out for that craft to then swoop out of the solar system, going north out of the plane of the solar system, and would not encounter any more planets.
Because the reason was because we wanted to get a close-up of Triton. And the penalty was, if we wanted to get Triton, Voyager then had to leave the ecliptic plane and go out of the ecliptic plane and disappear. And so it's now headed northward toward the polar star. And Voyager 2 will actually be bent downwards, or has been bent downwards by Neptune, and is headed southward out of the ecliptic plane.
And Triton was a very interesting natural satellite in that it was confirmed to have an atmosphere and many other interesting things about it. So it's probably a good choice, right?
Yeah, I think so.
Where would Voyager 1 have gone had it not been routed around?
Same place, same way.
Same way.
It could have gone the same way.
It could have also gone past Neptune.
Right.
All right. Thank you, Zeke, for your question. Do we have another call? Bill in St. Louis. Good morning.
Yes, good morning. These are great images.
Aren't they? They're spectacular.
You mentioned earlier about the 22-watt transmitter on board to transmit these images to JPL. It's not a regular, what is it, a laser? What
No.
Transmitting?
It's a normal radio, a vintage 1960.
A 1960 vintage radio and a 1977
it's not a laser. It's a radio transmission. You know, a carrier beam modulated with information. And in order to use that radio as an atmospheric probe, we just leave off the modulation and use it as a pure sound, as a pure tone, and then the atmosphere of Neptune and Triton changes that pure tone, and we can tell things about the atmosphere from receiving that changed tone.
I think it would have been impossible because of the primitive development of the laser.
Well, there isn't enough power.
There's enough power.
It would have used a high-power laser, and we just wouldn't have had that much power on board.
Well, you know, I'd like to add to our panel of experts here today Dr. Science, who is the author of the official Dr. Science Big Book of Science, and originally from Duck's Breath Mystery Theater in San Francisco, who's been quoted as saying, "There is a thin line between ignorance and arrogance, and only I have managed to erase that line."
Oh, he's a real expert then.
Oh, he's a real expert. So, Dr. Science, welcome to Neptune All Night.
Why, thank you, Serge.
You're an outcast in the scientific community, but have you managed, despite that, to slip any experiments aboard the Voyager 2?
I wasn't asked, but yes, I did. I managed to put a poorly maintained Hoover vacuum cleaner from the early 50s on board the Voyager. And we were going to answer the question, if sound can't travel in a vacuum, how come vacuum cleaners make so much noise? Scientists have been trying to answer this question for years.
And has your research proved fruitful?
Well, of course, yeah. What we found is that in the clean atmosphere of deep space on the way to Neptune, that thing made absolutely no noise at all. Even when the ball bearings were about ready to fall out, the belt hadn't been replaced since 1959. The thing was absolutely silent. But once we got near Neptune, we began to pick up small particulate matter, and that thing began to roar so loud that, well, that's what the input-output graph on the side of your screen show, the increasing noise level of that Hoover.
I see, and I can see that it's increased in particular in the past few minutes there at the top.
Gotten real loud. You wouldn't want to be out there. It'd be deafening.
We've been talking, Dr. Science, about Neptune and the solar system. What do you see from your laboratories?
Well, of course, I see more than most scientists. That's why I'm an outcast. That's why they've taken me and made me live in my own basement laboratory here in Iowa. But what I see is that Neptune has more of an atmosphere than I would have ever expected. So do its different satellites, the ones named Goofy, Dumbo, Oswald, and Grumpy, and Thumper, actually. Disney renamed all those satellites in the 30s. They used to have Latin names that no one could pronounce or care about. But when Disney started with the outermost planet, named it Pluto, that caught on as a cartoon character immediately. The other ones, the ones that Carl Sagan calls Uranus, that some of us call Uranus, that was originally called Oswald. But anyway, these planets and satellites all do have quite an atmosphere, what the French would call an ambiance. It's a mysterious, exotic, with a hint of the naughty.
I can tell that your contributions to the literature will be welcomed greatly with appreciation. Tell me, Neptune appears to be a perfect sphere. Do you have any comments on that?
Well, it had to be manufactured that way. See, all the planets are flat, including Earth. Anyone with 2 brain cells that connect knows that. But these things, these landings and these photos from the Jet Propulsion Laboratory that purport to be from NASA actually all come from a soundstage in Arizona. It's all part of a vast conspiracy, Sedge.
And you have seen the soundstage?
Oh, yeah, you can tour it. Of course, we'll just tell you it's a television station in Phoenix, but we who can see behind the conspiracy, who can see the workings of the International Communist Party, the International House of Pancakes, the Vatican, we know their work.
Well, there's no question why you're treated as an outcast in the scientific community with your avant-garde ideas.
Thank you.
Hi, thank you very much, Dr. Science, for stopping by. Oh, by the way, anyone here have a question?
Yeah, I think now he did it. Now my kids will want to become scientists too.
Your kids will want to become scientists
after hearing this.
Yeah. Mike, you have a question?
I'm curious if he's working on his PhD, or will he always have a master's degree in science?
Oh, I would never sell out and go that doctor route. No, I'm not a real doctor. My first name is Doctor, and a PhD would be an insult to my intelligence. I awarded myself my master's degree, and of course my message to Americans is you could do this too. Simply have the courage to make yourself an expert.
You mentioned the Vatican in this conspiracy, and I wonder if the Vatican had anything to do with the Hoover that's installed, the vacuum that's on the vacuum cleaner.
Yeah, the Vatican. Well, most things. If you read the books of Robert Ludlum, and if you read various exotic magazines, you'll find that most things are actually a front, a conspiracy between vague powers. We know that Elvis and Marilyn Monroe's bodies are in the basement of the Vatican being preserved. We don't know why.
Well, I want to thank you for your particular perspective from your basement laboratories in Iowa, Dr. Science. Thanks very much for being here on Neptune All Night. Good night. We're going now to Don in Los Angeles. Any conspiracy theories you have? Don?
I don't think that was funny. I think it was very serious.
Oh, you think it was serious?
I think we ought to investigate that.
Hello?
Hello.
Hi, yes, my name is Don from Los Angeles. First of all, I'd like to give my congratulations and admiration to all the people that had a hand in this. Also, I have a question here. Is there going to be any follow-up expeditions to the planets that are like a major priority on the list of explorations or anything like that?
First of all, there have been a great deal of people behind the scenes, and I urge you to stay and watch their names go by at the end of our broadcast in about 10 minutes or so. But Jessica, any
well, yeah, of course, you probably have heard about the Magellan going to Venus, which has been launched by the shuttle in May '89. And then there is Galileo, which is a real biggie, much bigger than Voyager, leaving Earth October 12th, launched by the shuttle on STS-34, going to Jupiter with an entry probe, actually a kamikaze probe going into the Jupiter atmosphere and radioing back data until it runs out of life. And also consisting of an orbiter which maneuvers around the Jupiter system, visiting most of the moons for 3-4 years. So that's going to be a real circus. And then there is the Hubble Space Telescope, which will catch up and will do a lot of, fill in a lot of the gaps in our knowledge about the distant stars and the universe. The Ulysses probe is a solar probe which will leave the ecliptic and go over the poles of the sun, the North Pole and the South Pole of the sun, where no one has ever been and ever looked down.
Does the satellite have to be protected in a special way to go?
Yeah, it has special thermal shields, of course, and much more importantly, we wouldn't have the rocket power to launch it there. It has to go all the way out to Jupiter to use Jupiter as a swing by, as a gravity assist, and then it comes back all the way to the sun, going over the poles. But we wouldn't be able to launch it out of the ecliptic just with our rocket power. We just don't have enough energy to do that. So we are facing very exciting years, and Voyager is just, you know, the first drumbeat of a whole series of highlights coming.
We go to Arkansas to Bill. What's your question?
Yeah, I was wondering, it seems that ring systems have turned out to be the rule rather than the exception for the outer planets. I was wondering if anybody had any thoughts as to why that might be.
Derek, would you like to speculate?
Speculation. Some of that can be due to the fact that some of the moons are in poor locations, or could be in poor locations for stabilization, and in some instances it may be that some of the moons that were originally around some of these planets have been broken up into smaller bits and pieces and distributed as rings. So, as you say, it seems to be more normal than abnormal to have rings around some of these planets, and I guess that's good for us because it gives us something more to look at, something nicer to look at.
Pete in Los Angeles.
Yeah, hi. I find it interesting that the further we get away from Earth, the closer it brings people on Earth to each other.
Good point.
I'm wondering about the economics, too, of how possible this has been and the possibility for future space exploration and where you see it going.
We'll turn to our man from the
Well, I think that that Voyager was among the last ones which was mostly funded by the United States alone. I think that future exploration missions will be so large and complex and expensive that they'll be handled by international cooperative teams, whether it's Galileo, which is going to be launched next month, or the Hubble Space Telescope, or the Cassini mission, or the Krafft asteroid flyby. All of those missions are partnerships between the United States and, for example, the European Space Agency and Japan. So that should cut down on the expenses to just the United States and should share cost between users. But you know, in a general sense, the Voyager program up to now has cost about $865 million, which you have to spread over 12 years and over, you know, how many? 100 million taxpayers and over 60 worlds investigated. So it's just less than a penny per taxpayer per year per world, which is a real good bargain. So I think that the economics of solar system exploration with unmanned probes can't be beat.
And that's Jesco von Puchhammer, a strategic planner from the NASA Office of Space Flight of NASA, who's been a great boon to us tonight, setting everything into context and describing some of the nuances and the technical ins and outs of this extraordinary voyage of Voyager 2. Also would like to thank Judy Moffat, science fiction writer, who is here for a good part of the night, as well as Jack Horkheimer, the star hustler and the director of the Miami Space Transit Planetarium, who is also left by this time. They both had previous commitments, as we extended our broadcast by a couple of hours today to take advantage of these new images coming from Triton to bring them to you. We'd also like to thank Franklin Institute Museum here in Philadelphia and their wonderful representatives who've been here today, Derek Pitts, Mike Weilbacher, and Joyce Town. A summing thought, Derek?
It's wonderful to be able to learn more about these moons that are at such a great distance, and also to learn more about our solar system. The more we see, the more we understand about the neighborhood we live in. I would hope that we might be able to put together a mission specifically to help bring mankind a little bit closer together.
Joyce?
I hope that everyone will follow up, if you're interested in these photos, by trying to get some periodicals or books in the coming weeks and months, and seeing these pictures in better resolution and perhaps with color if you'd like to. It'll really be exciting for you, I think.
And Mike?
And we at the Frankel Institute will be doing some of these shows. We'll be showing some of the images, and I imagine other science museums will do the same. Don't want to forget, we've been going crazy over the Triton images for the last 2 hours, but Neptune's still there, and we still have lots more to learn about Neptune and its arcs, rings, the surface structure, and so forth. So it's been great to be here.
And thank you, Mike, where you can hear his live call-in radio show for kids called Kids Corner on WXPN FM here in Philadelphia. A closing thought from you, Jessica.
Well, I appreciate having been here. It was a unique experience. I never forget this night. You know, we've been here now for 9 hours witnessing such a unique event which will never happen again, at least in my lifetime and in probably most people's lifetime. So I really appreciate that, and I was so tickled by the interest we caused across the nation. All these telephone calls showed that we were able to pass on a little bit of our excitement. I just hope that this excitement can be sustained and that people will continue being interested in what we're doing and keep following Voyager for the next 100,000 million years out there.
Thank you very much, Jessica, and on behalf of everybody and those behind the scenes, this is Sedge Thompson saying this is Neptune All Night. Good night. Neptune All Night is made possible by the financial support of viewers like you.
You've been watching live coverage of the Voyager satellite's journey past Neptune. We now return to our regular program schedule